We're going to continue talking about renal physiology, and we're going to focus primarily on the distal convoluted tubule. And we can see here from a conceptual standpoint that the distal convoluted tubule is involved with the reabsorption and secretion of certain ions and happens to be the site of regulation of calcium and phosphate via the parathyroid hormone, and also happens to be the site of thiazide diuretic activity. For example, hydrochlorothiazide binds to the distal convoluted tubule and acts as a diuretic for the treatment of hypertension. So we can see here that the distal convoluted tubule is involved with the reabsorption of sodium and chloride, water, potassium and chloride, as well as bicarb. And the secretion of the distal convoluted tubule is involved with the H plus proton, or the hydrogen ion, potassium and calcium. We can say that the distal convoluted tubule receives a hypotonic tubular fluid due to the countercurrent multiplier that occurs within the loop of Henle, and provides a hypotonic solution, although there's a hypertonic interstitium within the medulla portion of the kidney, or the medullary portion of the kidney, but the end result is a hypotonic solution within the tubular fluid that enters into the distal convoluted tubule. The distal convoluted tubule is almost considered as a connecting segment between the loop of Henle and the collecting tubules. And approximately 5% of the total ultrafiltrate that was formed by the filtration process of the glomerulus, which filters the plasma into the ultrafiltrate with high concentration of sodium. And we said before that the proximal convoluted tubule absorbs approximately 65 to 75% of the sodium. And then as the ultrafiltrate enters into the loop of Henle, we said that approximately 20 or 15 to 20% of the ultrafiltrate of sodium is reabsorbed. And we can say in the distal convoluted tubule, approximately 5% of the sodium is reabsorbed back into the systemic circulation. We can also say that the parathyroid hormone acts at the distal convoluted tubule, and that helps to secrete phosphate from the circulation into the tubular fluid to be excreted via the urine. And it also helps to increase the calcium that enters into the circulation to increase the calcium concentration. And as we said before, this is the binding site or active site of the thiazide diuretics, for example, hydrochlorothiazide, which helps to bind to the chloride receptor, the chloride portion of the channel that allows for sodium and chloride and potassium to enter into the tubular cells. The chloride portion is bound and inactivated and prevents the reabsorption of these ions, and therefore they pass into the collecting tubules and promote diuresis and therefore help to treat hypertension.